Okay, today we're going to be working on proportions. What we want to do is we want to define and write proportions. We want to solve proportions with the three-step method. A proportion, first of all, is two equal ratios. Proportion can be written two different ways. The first way is using what we call colon notation. Notice that the ratio 7:39 has the colon or the standard form for ratios being used. And then it is being compared to, you have double colons, 28:156, which is a second ratio. You can think of these double colons here as an equal sign. Okay, so we can have it in colon form or we can have it in fractional form. Fractional form, I have 7:39 written as a fraction equal to 28:156. So either way is a proportion. Now, I can write any proportion I want to write. That doesn't necessarily say that it's a true proportion. So, many times people will write proportions, but they may not be what we call true proportions. So I'm going to take this proportion that I've written, 7:39, as 28:156, and test it to see if it's a true proportion. You have done this technique once before. If I take the denominator of one and multiply it with the numerator of the other, and I get the product, then take the denominator of the other and multiply it with the numerator of the other, and get the product. As long as the cross products are equal, then I have a true proportion. Go ahead and do that and see if you can test that this is a true proportion. When we multiply 39 times 28, we get 1,092. And when we multiply 156 times 7, we get 1,092. So because both of the cross products are equal, then this is a true proportion. Now in your packet, after the review of ratio proportions, actually ratios and rates, you'll have an exercise on page 5 where you have to determine whether the given proportion is a true proportion or not. So if you turn to page 5 in your packets, you can be working on this while you're listening to me on the lecture here. You're going to do the cross products, and then if they are exactly the same product, you're going to go, yes, this is a true proportion. If the cross products are different, you're going to say no, it is not a true proportion. So yes if it's true, no if it is not true. Okay? Now I'm going to continue to lecture while you're doing that, okay? So you still need to listen to me. I said listen to me, don't you say what? Okay. We have a three-step method that we can use to solve proportions. And I told you guys to practice saying this yesterday when we were doing rates. So, what was it I had you guys say when it comes to these three steps? What's the strategy? Set it up. Cross multiply. Divide. Now let's say it all together because I don't know what happened to y'all. Okay, ready? Set it up. Cross multiply. divide. Now today you're going to actually do those steps to solve your proportions. And I love it. Alright, so if I tell you to solve for x, and it just so happens that I was very sympathetic at first and I decided to give you the setup. You already have the setup. So after we have the setup, we're going to do cross multiplication. Now, if I look here crossways, where do I have two real numbers? That's where I cross multiply, is where I have two real numbers. And you can circle the 3 and the 35 or just put an arrow there to show that you multiplied those two for your cross product. Now, what am I supposed to do in step 3 after I've cross multiplied? Divide. Divide what? I'm supposed to take that product in step 2 and divide it by the number left over. What number is left over? So I need to divide 5 into 105. How much is that? 21. So my x is 21. Okay? And you can just think of x as the unknown or the empty box. Okay? Set it up, cross multiply, divide. The reason this one was so easy is because the setup was already done for you. Be sure to cross multiply where you have two real numbers and then divide that product that you got in step 2 by the number left over. And the number left over in this problem was number 5. 5 goes into 105. Any questions about how to administer this strategy? Now, one other nice thing about this strategy is you know how to test a proportion to see if it's true. So if you plug in 105 here where the x is in the original setup, and you get 105 and then 105, because those cross products are equal, you know that your answer is right. You have a true proportion. You can check your own answer. You don't have to go, Miss D, am I right? You can check it for yourself by doing the cross products. I love it. Okay, so for this problem, I've given you the setup, and I want you to tell me what to do. What do I do in step 2? What am I going to multiply? 7.8 times 11. I have to cross multiply where I have two real numbers. That gives me 85.8. And then what do I do with the 85.8? Divide that by 6. So 85.8 divided by 6 gives me 14.3. So y is equal to 14.3. And I can just substitute 14.3 where y is and do my cross products to make sure that they're right. So you can check your answers. Now these types of problems are in your packet, starting on page 7 and ending on page, I think, 11. Excuse me, page 7 through 11. So you can do it. You already have the setup. You just need to cross multiply and divide, cross multiply and divide from page 7 on to 11. You need to keep in mind how to handle your multiplication and your division of decimals and fractions. Because sometimes you might have to multiply a fraction and sometimes you might have to divide a fraction. Okay, it's not going to be nice, simple, whole numbers all the time. Also notice that when we're missing something in our proportion, it is not a ratio. It can be a whole number, it can be a decimal, or it can be a fraction. And they need to be simplified all the way down. Okay, so these are not ratios, these are actual numbers. Now, this is where everybody has trouble. Taking a yum-yum, give me some, and setting it up. This is where the issues happen, okay? Now, I've solved this problem on the board, but I'm going to go through the PowerPoint to show you how I set this up. This is a typical proportion problem. Mike constructs a scale of a building, an actual building. He says that 3/4 feet of the height on the real building equals 1/5 inches of height on the model. So the building's ratio is 3/4 feet, and this is 1/5 feet for the model. Now the question says, if the model is 5 inches tall, the little model that's representing the actual building is 5 inches tall, how tall is the actual building? We don't know. It's an unknown. We have to figure it out. It's a typical proportion. So, in this problem, what is the given ratio? What ratio did they give us? 3/4 height of actual to 1/5 height of the model in inches. And the 5 inches is on what? The 5 inches is on the model, right? So, you need to keep the same unit on the same row. So, I wrote this proportion up this way with the setup. Keeping the same unit on the same row, I have feet first and then inches. Feet is the model. Feet is the actual and inches is the model. So if you want to put feet actual, you can. If you want to say inches model, you can, okay? Whichever way helps you. I just said feet and inches. So I know that 3/4 feet of the actual building corresponds to 1/5 inches of the model. And they told me the model is 5 inches high or tall. So I need to find the actual height of the building. So what I'm going to do after I've set it up, I kept the same units on the same row. I have a question mark for the actual height of the building. Where am I going to cross multiply here? 3/4 times 5. Well, I better remember how to multiply fractions. So 3/4 times 5 is where I have two real numbers. And 3/4 times 5 over 1 will give me 15/4. Now, what am I going to do with this 15/4 in step 3? Divide by what? By 1/5, because 1/5 is the number that's left over. So I have to take 15/4 and divide it by 1/5. Well, this is fractions. So I have to keep, switch, and flip. That's exactly what I did. Keep, switch the operation to multiplication, and flip. Now, I can't cancel anything, so all I did was take 15 times 5 is 75. And 4 times 1 is 4. When I take 4 into 75, that's the same as 18 3/4, or 18.75. And that's feet. Are there any questions about the setup, the cross multiply, or the division in order to get that 18 3/4 feet? Yes, Ayub. Well, you should know by now that 0.75 is the same as 3/4. Or when you divided it, you'd have 3 left over, and then you just write it as 3 over 4. I just wanted to show you that they're both the same. One's in fractional form, one's in decimal form. And personally, for this type of problem, the fractional form is a little bit more accurate because it has to do with customary measures. So I would have used the answer 18 3/4, but I know a bunch of you like to use decimals. They mean the same thing. Okay? Let me know when you get all those notes down, because this one's kind of hairy because of all the fractions. So when you have word problems, the biggest thing to do is to take your time, hunt for the ratio that's given, write those units down, keep the same units on the same row when you set up your problem. Because I could have put the inches first on top, just keeping them on the same row, and the feet on the bottom, and I still would have gotten the same answer using the set it up, cross multiply, and divide. Okay? Good? Okay, great. Don't forget, when you write your final answer, you need to write the units that go with it. So we were looking for feet here. So I wrote 18 3/4 feet as my final answer. Don't forget to write those units down. Okay, any questions? Can I change the page yet? Yes or no? Yes, okay. All right, now let's test your skills here. Candy got 4 hits and 8 bats. Jason got 3 hits and 6 bats. The coach says their batting ratios are the same. Which expression shows that they are the same? 1, 2, 3, 4, or 5? You can ask your table mates to help you if necessary. Which one is accurate? And let me know when you have your answer. Okay, I've got number 2 as a choice from somebody. Jamar, you said number 2? Are you saying number 2? Which answer are you saying it is? Okay. What's another way that I taught you how to do this to check it? You don't have to reduce them down. What was it that I just taught you today that you could use to verify? Cross multiply. So if I cross multiplied 8 times 3, what would I get? 24. And what's 4 times 6? And what did we say if the products are equal? It's a true proportion. So that's how you know. Okay? That's also how you check your answers when you're doing proportions. So you could just check with cross multiplication. Any questions on this? I know on the GED they love to do this type of problem. They'll give you some sort of, well, on the compass they might, they will have proportions on there, and they could have one like this, where you have to verify it with a true proportion. Yep. I had a student this morning, he's trying to take the military test, and he came over to me and he asked me, he says, Can I get some practice with arithmetic reasoning? And I said, well, what is that? Let me see what that looks like on the test. So I looked at the test, and every single one of those was a proportion. And I said, you know, you've been fooling around today, and you haven't done nothing. Well, what we're learning is the very first question that they showed you on that test. So you better get busy. And boy, did that get his attention. He started working on his packet. Okay? So arithmetic reasoning is the thinking process that you use to set these proportions up. That's all it is. Proportions and percents. Any other questions on this one? Let's do another one. I think I have one more. I hope so. Oh, I don't. I'm sorry. We'll have to use the ones in the actual packet. So let's summarize. A proportion is two equal ratios. A proportion can be written in two different ways, in fractional form and in colon form. Don't forget that ratios need to be put in lowest terms if you have a ratio, and you have to do that because we are going to do a few ratio review problems. They should never be made into whole numbers or mixed numbers, but that is not true for the answer to a proportion. An answer to a proportion can be a whole number, a fraction, or a decimal. One way to solve proportions is to use the three-step method of set it up, cross multiply, and divide. Remember, when you set up your proportion, you want to line up your units in the same row. On step 2, when you cross multiply, you want to cross multiply the two real numbers. And on step 3, you want to take the product from step 2 and divide it by the number left over in the proportion. Also remember, you can use the cross products in your final answer to check your answer to make sure it's right. You don't have to ask me if you're right. And using this method to solve proportions will help you solve problems in real life. Let's get to the packet. All right, the first couple of pages in your packet are a review of what we did yesterday.